Hello, I am Jesu Manuel D. Guangco, and we're gonna talk about the colligative properties of salt in water. Salt is used in everyday life. We use salt in cooking for its flavoring capacities. Sometimes, salt is used while cooking pasta, in which salt is added to the water. Though it is used for flavoring, it does raise the boiling point. If you add salt to water, you raise the water's boiling point or the temperature at which it will boil. This is an example of boiling point elevation. It is not exclusive to water. It occurs anytime you add a non-volatile solute, such as salt, to a solvent, such as water. First, what is boiling point elevation? The boiling point of a liquid is the temperature at which its vapor pressure is equal to ambient atmospheric pressure. Since the vapor pressure of a solution is lowered due to the presence of non-volatile solutes, it stands to reason that the solution's boiling point will subsequently be increased. Now, how does salt increase boiling point? When you add salt to water, sodium chloride dissociates into sodium and chlorine ions. These charged particles alter the intermolecular forces between water molecules. Here is an example problem. 31.65 grams of sodium chloride is added to 220 milliliters of water at 35 degrees Celsius. How will this affect the boiling point of the water? Assume that the sodium chloride completely dissociates in the water. The density of the water and the molal boiling point elevation constant is given. So, we will use this equation. Step 1. Calculate the molality of sodium chloride. The molality of sodium chloride equals moles of sodium chloride over kilogram of water. First, we need to determine the moles of sodium chloride. Then, we need to determine the weight of the water by kilograms. Now we can input the values, which equals to 2.477 mole per kilogram. Step 2 is determining the Van 't Hoff factor. The Van 't Hoff factor is a constant associated with the amount of dissociation of the solute in the solvent. Since sodium chloride dissociates into sodium and chlorine ions, it would only dissociate into 2. Therefore, I equals 2. And finally, we can now find the change in temperature. After we input the values 2 times 0.51 degrees Celsius kilograms over mole times 2.477 moles per kilogram, we get 2.53 degrees Celsius. We can now conclude that 31.65 grams of sodium chloride to 220 milliliters of water will raise the boiling point by 2.53 degrees Celsius. In conclusion, colligative properties are in our daily lives. From as simple as salt and water, imagine how many more can we discover. Thank you for watching.